Der Bauer sent me something that I wasn't wiping the chip off my shoulder. That's always gonna stay there. That was fuzz. Anyway, I knew this was coming for a bit. I've been super excited about it ever since we saw the first WireView. This is the WireView 2. You know, as long as companies keep making bad products, guys like Der Bauer are gonna exist to counter their bad product with a better product. So I'm really excited for this one. Today's video is brought to you by our brand new GPU Apocalypse 2.0 shirt, kind of immortalizing all of the stuff you love about today's GPUs. Our GPU Apocalypse 1.0 shirt was actually one of our most famous and popular shirts, and now it's re-immortalized with GPU 2.0. But let's face it, the Apocalypse never went anywhere, it just evolved. Just like this shirt. Go buy it now. Okay, those are the new ones. These are the old ones actually. If you don't know what the WireView is, this was something that Der Bauer, Thermal Grizzly founder came up with to give you some readouts so you could see like power draw, amps, watts, all that sort of stuff. But it was very basic. You can see it even came in, standard PCI Express, like 8-pin and 6-pin layouts. All the different types of GPUs out there. Some used 3.8, some used 2.8, some used an 8 and a 6, some used 2 8s and a 6, weird numbers. So they came out with all these different ones. I have the 12-volt high power ones somewhere, but these are just the PCI Express versions, and I wanted to show you kind of the first version so that you knew how really awesome the second one is gonna be. Now look, I have 3 different 5090s on the table right here. The 4090s and the 5090s are by far the most susceptible to the melting connector problem. And that's clearly because they pull so much power through the very small gauge and very small pin of the 12-volt high power / 2x6. But that's not the only ones that are failing. We've seen 4080s fail. Heck, we've even seen the 9070 XTs from Sapphire have melting connector problems, and they pull half the power of a 5090. So clearly there's a bigger design flaw. Now, love or hate ASUS, I really don't care. You can love and hate whoever you want. That's the beauty of being an individual. Little pluribus throw out right there. The ASUS cards, specifically the Astral, we'll just pretend this is an Astral. If you watch my other videos, you know my Astrals have some problems. Another issue we've kind of learned about, and I'll mention this real quick. If you haven't seen the previous video, I showed how 2 of my Astrals have corner pins that pushed in. It's like the cable wasn't perfectly centered on the pin. There was a little bit of play in there, so the pin just hit the cable hit the pin and then just shoved it in and basically did that to it. The reason why I think that could happen is because the Astral has individual pins that go to their individual senses instead of like a bus bar on the backside, which a lot of the other graphics cards have, where there's like a bar on the back because it's just a unified ground and a unified 12 volt. It makes each of those pins a little more delicate to where if it's not perfectly centered, it could push back. My air-cooled card was that way too, and I didn't even realize it. So that is like a byproduct of an amazing design that it gives you per pin amp sensing, but it's kind of more delicate now because it doesn't have that solid bar behind it, giving it more rigidity. But it's the only brand really right now giving you, and this is not an ASUS spiel, I promise, it's just what Der Bauer's kind of done is taken this technology and made it applicable to any card. It doesn't matter if it's a 5090, 4090, an AMD card or whatever, it gives you the ability to monitor the amps per pin. Even if your graphics card doesn't have it built in like the Asus Matrix and the Asus Astral cards do. Like I've got a Gigabyte card right here, which does not have a unified, or does have a unified 12 volt plug on there, but it does not have per pin sensing. The reason why I'm bringing up the fact that the pin smushed backwards is that particular pin, although it worked because it was still making physical contact, was making poor contact. So I suspect that it's one of those issues where it would be fine until it wasn't, right? Now the Astral card fortunately would tell you hey, this pin is really out of spec, right? But no other cards will really do that. Now, what this allows you to do with the WireView is not only keep tabs on each of the individual pins' power draw and resistance too, it also has a safety shutdown feature. As long as you wire the start button or the power button for your case into it, If something goes above spec, and you can control the spec, not all cards are gonna be the same. A 5090 is gonna pull anywhere between 9 to 10 amps per wire, whereas like a 4080 is gonna pull more like 6 to 7 amps per wire, right? So you can set that threshold where you want it to be, so that if something goes out of spec, and it goes out of spec for a certain duration of time, I think it's 10 seconds by default, it shuts the system down, and that would stop anything from happening. And the reason why I have these different cards on here though is, although it's an amazing design, it's not compatible with all cards. So we're gonna kind of look at 3 different styles right here to give you an example. Actually, technically 4. I gotta grab the old Effie as well. We'll take a look at this and then we'll kind of run it through a test, and then we'll set up a scenario where we can make it fail. So they're both essentially the same thing. You'll just notice one is normal and one is reversed. And that's because essentially you have like an Asus version and an everything else version, because Asus, their 12-volt plug is essentially flipped, reversed, to where the little catch tab is on the top. Actually, the Gigabyte is the same way. But if we look at the Founders Edition card for like the 4090, you can see the little clip to grab the cables on the bottom. So you could technically run it either way. It's just depending on which way you want the actual cables coming off the WireView to go. So let's go ahead and take a quick unboxing and look at this. I know these just came out. Wow, this thing's beefy. If you compare it to this is about the size the 12-volt version is for the WireView 1. That's the WireView 2. But that's because there's also a fan in there. So that fan is just good measure, especially if you're running something like a 5090, 4090 tier card. The cables can get pretty hot. So anything you can do to just reduce the amount of temperature at the plug is only gonna help, but no fan is going to overcome the runaway effect that's gonna happen with the temperature and then melting of the plug if you have a failure where the amp draw is just starting to run away. So that will fail. But that's the whole point, is we'll turn this off, or turn the card off and the system off before any of that ever happens. So the only reason why I have the matrix here is because I want to know, because we know the matrix has this really recessed plug. I want to know whether or not this thing would have even been able to reach in there. No. Oh, if only it was a few millimeters longer. Yeah, it doesn't click. Oh, if it was just a few millimeters longer. That would have actually looked kind of neat in there. Now, to be fair, the graphics card has this feature built in, but if you don't have GPU tweak running, it won't warn you and it won't do anything. That's the downside. You have to have their software running, where this is a hardware thing. There's no particular software that has to run in accompanying with this. It all happens internally on the device. So that's the only reason I had the matrix there. I was curious as to whether or not it would reach with that really recessed plug. Nope, unfortunately not. Now here is the Gigabyte card. This is technically upside down. So this one is the normal. So if you're running like a Gigabyte card or any card that has the retention clip on the top of the card, then technically you want to run the reverse. There we go, did you hear that click? There. Now we've just installed safety. Now the reason why I have the Founders cards here is because the 5090 or the 4090 right here is a normal. Now, one of the reasons why it's spaced out as far as it is you still have to have room to be able to get in there and release the tab, which is why if it was even slightly longer, it would have been cool because it would have worked on the matrix. I mean, if you spent $4,000 on that card, I want every possible safety feature in there that I can get. But if you're running the 50 series Founders cards, because of the funky angle, it's not gonna work. So they switched the cable from this flat style, like on the 40 series, to this angled style, which is nice for like cable management, but now you can't actually run it. Now you could, it would be a bit ridiculous, but you could run this inline technically. Like you could just have it somewhere else, but now you're adding more connection points, which is kind of a problem because as you can see, your normal cable is just gonna plug into the bottom. So I could technically like mount this somewhere else and then have it go extension cable from there to there, and then power supply cable into there. You could still do it, but it's not exactly going to be recommended. Now you might be asking yourself, Jay, how does it shut down the system? Well, it has a harness that plugs in, and basically it becomes a splitter for your power button. Now, it's not gonna work with unified power plugs or front panel connector plugs, which is something we've been seeing more and more of in modern cases, where instead of having the individual power button, reset button, hard drive LED, and power LED, it's just a single connector. It looks like a USB 2 connector. But that doesn't mean you're out of luck. You can actually just go on Amazon and get yourself front panel extension harness, which then just would plug into the unified connector. You can zip tie or tape that together so it doesn't come apart, like tuck it away in your system, and then you would just have the individual leads. And they're like $4, $5 on Amazon. So you're not out of luck if you have a unified connector, it's just you're gonna need that extra piece. I know DeBauer said right now that he didn't have a solution for that yet. I'm wondering if he might be able to come up with an option to include that. Maybe they're not that expensive. They're just the front panel connection extenders. In fact, let's see if that cable's in here. It should be. Okay, we even have temperature probes. Holy cow. We do have a temperature sensor here, because if you notice on the bottom, we have more than just our shutdown harness. So you've got 2 temperature probes, which are the bigger plugs. You have the smaller plug, which is gonna be the front panel connector tie-in, and then you have USB-C for firmware updates and programming. As you can see right here, there's our temperature probes, which I guess is kind of nice because you can technically put those wherever you want and have an additional safety feature, or just have the data showing right there. And then this is our front panel connector. But the idea here is that this is just going to plug in the front right here, and then you could just zip tie it along your 12-volt cable, right? And you got a lot of length. So, all right, let's go ahead and let's wire this puppy up. All right, it's wired up. I'm using the splitter for the power cable, as you would expect. It's very delicate wires. They're very thin, so be careful. But like I said, I would just zip tie these like along your power cable, just to keep them kind of nice and neat. They blend in. You don't need the USB-C to make it run. That is literally just for programming, like I said. I don't have any of the other temperature sensor probes plugged in right now, but if I did, they would show up on here. So we got 24 or 25 watts currently, peak voltage. Oh, that's cool. It'll show you the peaks. Pin 6 is at 0.4 amps. Yeah, okay. So it's just saying 0 amps because it was rounding down because it's at 0.4. Average volts 12.1, max temp 20C. There it is per pin. So this is probably the view I would personally leave it on at all times, even though it has some other stuff that's pretty awesome. But each click basically cycles through the different menus. You can see TS1, temperature sensor 1, TS2, temperature sensor 2, but it has its own measurement like in line of the actual power going through the adapter as well. So even if you don't plug in those temperature sensors, it still will monitor temperature, which is what's gonna also control the fan. And then you can see right here our current firmware, USB connection, not connected. And then we're back to the main menu there. So we can long press to go into the menu. So current scale, 10 amps. But it's set to 10 amps right now, which by default would be 5090. We can set it to 15 amps, I guess, if we were doing overclocking. 20 amps if you have a death wish. And then it can go all the way as low as 5 amps. We can also power scale. This is wattage right here. So 600 watts by default would be 5090. We can set it to auto, 300, 600, and auto. So I'm gonna leave it to 600. So we have temperature source, max, in, out, TS1 and TS2. Okay, what I wanna show now is that each menu each page kind of gives you a different menu. So if I long hold on the main page right there, you can see, this is where I was just showing you the amp state and all that sort of such. And if I go to, let's say, the actual firmware page right here, then we get even more menu settings. So now we have fan control set to auto, pin current limit, total power limit set to 660 watts. There has to be some headroom for something like a 5090. The card will say it's pulling 600 watts, but to supply 600 watts, it pulls more than that because of droop and efficiency loss through heat and all of that. So that's why we showed in our WireView, and that would be a 600 watt card. It can pull up to like 630 watts through not the WireView, but the PMD. It'll show up to 630 watts in the PMD. So this has to be able to allow for some of that efficiency loss and headroom. It's set to 660 watts by default. But if you wanted to do like overclocking with this and use this to protect your XOC card from dying, which is something I probably should have done, this would have saved me from having to have that connector replaced. We can actually adjust this. There's 7, was it going up by 50 watt? Yeah, it's going up 50 watt increments. Geez, der Bauer. 1300 watts, 1400 watts. Okay, so the crazy thing is we've seen transient spikes that go that high. Anyway, temperature limit ADC, that's specifically referring to the connector in the cable. It won't melt at ADC. Auto shutdown wait. So that says 10 seconds by default is how long it will sit out of spec before it shuts your system down. Now you can change this by 1 second increments up to the minutes now. Okay, I'm gonna go back to 10. The only reason I can imagine why you would want it to go up into like that 3-minute range, or maybe in that 4-minute range, is because you can have these thresholds that can be exceeded for XOC purposes, and you can set it for longer than the test duration is, and then you can make it so you can do the run without it shutting down in the middle of the run. But you still have the protections there. Again, you'd have to set the thresholds and all of that. But it's cool that he's giving you, you can tell Der Bauer was a XOC champion for many years because he thought about this stuff. So it's like consumer safety, but also like prosumer safety as well. So we can still use it to keep from killing cards while doing crazy OCs, as long as we don't kill it for voltage reasons. Shutdown behavior. Hard shutdown means that's basically you held the power button. You can do a soft shutdown, which would be if you have it set in Windows to like, if you tap power, it shuts down. It can just tap the power too, which would be safer because let's say you're working on something, it gives you an opportunity to, I don't know, maybe potentially have it do a soft, I don't know if that would help. But the OS never likes to be hard shut down, but I think it's better to hard shut down the OS than to hard shut down your hardware. So, and by that I mean having it melt itself to death. Okay, I'm gonna see what the theme is because I don't care for the red personally. Much better, I can see now. Oh cool, there's no background. Okay, so you have 3, I like that better. I'm not a fan of the red. Oh, rotation. Oh, okay, that's kind of neat. So let's say you get a different card one day and you're like, oh man, it has to go the other direction. Well, at least you could flip the display, at least you're not stuck. Display brightness is at 100. Log interval. So if you have it plugged in to the USB, you can actually do a log, like a temperature. You kind of like the time over, or the graph over time charts that we do. You could actually use this for logging. And then timeout interval, that's how long I would sit here without touching anything. It'll go back. And then timeout actions, just static. All right, so let's save all this. I am gonna turn the fan on though. I like the idea of the fan being on, even if I could just let it run slowly. It says it's going at 100%. Uh-oh. Okay, we're gonna test the fan now. Okay, well, you can see now I put the other WireView on and I had to rotate the display 180, so at least you see what the rotation does now. There, see now it shows the fan is turning. Fan is turning. So that stinks. I guess I'll send this one back to him and hopefully that's something that could be maybe fixed with a firmware update or something, because that seems potentially software related. Okay, this one's all working. Let me put this card under load real quick. Oh, I thought that one pin was gonna come up. I was like, what the hell?
It's still pretty jank though.
It's pretty uneven currently. So you can see the cable warming up, 34C. Still has the red colors though, dang it. I wish we could change that. Dang, that is some unevenness though on those pins right there. All right, so let's go ahead and simulate a card that is running out of spec, shall we? Let's say even 7 amps, it'll fail. Now what we should see is that come up with some sort of a warning. Now I have the scale set to 10 right now, but every single one of those pins is over. Man, we got 9.5 on that one and that was 8. Anyway, there we go. It's warning at us saying pin 6 is at 9 amps. Warning, current exceeded. And after 10 seconds, it should shut it down. There it goes. So, okay, so this system is set to where if you push the power button, it does its own shutdown. So that's why it started to do the shutdown, but I think it was because we're set to hard, it still shut itself down physically, like forcefully. That, I mean, you gotta admit, this is a nice thing to have. The fact that this even has to exist is kind of the screwed up part of all of it, because of the fact that the amount of engineering that had to go into this just to overcome poor engineering is kind of sad, to be honest. I'm gonna put my pin current back to 10. Here's the crazy part about that though. 10 might still not be enough to keep us from shutting down, because you saw that inconsistency across the cables or the pins. We've had certain cables at stock speeds around here go up to like 10.5 on a pin, and then maybe down to 8.5 on a different pin. So remember, it's always gonna balance out. That math is always gonna equal the total amp draw of the entire card. So if one pin's making a poor connection, somewhere else has to pick up the load. And usually that's gonna be the pin that has the best connection, because electricity, like water and air, wants to flow in the path of least resistance. So let me do one other thing. I wanna see what happens now if I set the wattage to something lower. Also, DeBauer, there's a slight bug here in your software. So it's at 660, right? Once you go around the bend, right now it's going up in 50 watt increments. But as we go around the bend, then it's at 50, and now it's in increments of 50. So when we go back up, it'll be at 650, not 660. I don't know if that was by design. So I just wanted to point that out. I'm sure you already know, but I'm just gonna set it to 400 watts right now. Okay, so it's gonna do the same thing. There it goes. Okay, cool. So you can set that temperature wise. So it'll shut down based on that temperature that's set for the cable in, cable out, the amps, and the watts. Before we get out of here, I'm gonna plug this one back in and see if the fan is now potentially working. That'd be weird, but I wanna see. Nope. Well, that stinks. Come on, buddy. Nope. It stops pretty suddenly. It goes, nyeh. So I'm wondering if that's just a bad bearing, perhaps? I don't know. But you know what's safer than one WireView 2? Two WireViews. Two WireView. Two WireView the sequel. Anyway, I was just curious if there's any discrepancy between the two. Oh, the fan's off on that one because I reset. 26 watts, 25, 27. Yeah, they would be with a couple watts of each other. But interesting. Let's see what happens now when we put it under load. Okay, it's clearly the cable, because they both are showing the right side having all the amps. Okay, so this is what I was saying. Look, one side goes all the way up to like 9.9, and down here is all the way at 7.3. Same thing over here, 7.3, 9.7. So it could be something to do with the power supply end, although this particular cable terminates into 8-pin PCI Express. But I was just pointing out, there's a huge imbalance. Like 7 amps on pin 1 and 10 amps on pin 6. Now here's the thing, it's not gonna shut itself down, but we are literally on the threshold. Like we're just about to cross it. If that was to go up to like 10.2 or anything above 10 for 10 seconds, it would shut itself down. All right, just one final test before we get out of here. I wanna see if we get that same imbalance right now. Obviously I'm not daisy chaining wire views. Not as bad, but definitely right side heavy. Like it goes up almost, kind of. I mean, it's a little better than it was, but that's still not very balanced. Yeah, it could just be this cable. We actually, it's funny that we have one here that's marked. It's the same cable. This is not one we've used very often. You can see it's never been bent right here, but do you see the pin pulling out right there? See that pin pulling out? You see the pins right there? See how that one's super recessed? So that would be one that's definitely giving us some problems on here. This is the kind of stuff you need to look out for. Oh, 12 volt, high power, lovely. All right, time to get out of here. I'm gonna message Roman or DeBauer about the fan going bad on this guy here, just to give him a heads up, like, hopefully these don't start coming back because of it. But one thing I forgot to mention too, I love that we put this little neoprene kind of pad on here just to protect the GPU if it does happen to touch, if it's a more recessed plug. But yeah, the really cool design. Awesome that DeBauer can build a business off of somebody else's shortcomings, at least expand his business built on it. But this is cool. If you have a high-end graphics card, I'll be honest, I don't even know the price of this. I know he's like pre-ordered that or pre-sold them, like pre-orders I've started shipping out. Ours were part of that bundle. Let's say it was even 200 bucks. That is worth protecting your $3,000 plus graphics card, right? Or even your $1,000 graphics card, even your $600 graphics card. It's cheaper to have this take the hit than your graphics card and then going through all the warranty crap, especially if we're about to go through GPU apocalypse again. All right, guys, thanks for watching. I'll put links to this down below. And as always, I'm not concerned about the fan on this because if there's one thing I know about Thermal Grizzly is they stand by their work, no questions asked. So that will be easily replaceable for them. All right, guys, we'll see you in the next one.